ಇದಂದ್ರೆ students, sorry for the interruption. I hope this problem will not arise in future. ಎಲ್ಲ ನನ್ನ ವಯಸ್ಸು ಕೇಳಿಸ್ತಾ ಇದೆ ಅನಿಸ್ತದೆ. ನಿಮ್ಗೆ ಏನಾದ್ರು ಸಮಸ್ಯೆ ಇತ್ತಂದರೆ ನೀವು ಚಾಟ್ ಬಾಕ್ಸ್ನಲ್ಲಿ ನಿಮ್ಮ ರಿಪ್ಲೈ ಮಾಡಿ. ಸೊ we have discussed the application of Henry's law. One thing is we can increase the solubility of carbon dioxide in a soda water or soft drink by sealing the bottle under high pressure. Second one is the bends. What is bends? The bends is due to the excess of the oxygen or the air dissolved in our blood. It releases during releasing it blocks our capillary. The medical condition is called bends. The bend can be avoided by the air cylinder is diluted with the helium gas. Third one is anoxia. Anoxia is due to the low partial pressure of the air. At higher altitude, the partial pressure of the air is less. Therefore, this causes the dissolved oxygen in our blood is less. This leads to the medical condition is like the person become weak and cannot think clearly. This medical condition is called anoxia. Okay. Say we shall move to the another thing. Before that, I will just recap what we have discussed in a solubility. In solubility, we have discussed what is solubility, what are the factors affecting the solubility of solid in liquid, and what are the factors affecting the solubility of gas in liquid. There we have discussed the solubility of the effect of pressure and effect of temperature. The effect of pressure is explained by the pressure is Henry's law that we shall discuss. We have already discussed it. One more thing we have discussed, the effect of temperature. After that we have discussed the application of Henry's law. So we shall move to the another part in this chapter, the vapor pressure of the liquid solution. Vapor pressure of a liquid solution. Vapor pressure of a liquid solution. What is the meaning of vapor pressure of the liquid solution? What is liquid solution? In liquid solution, the solvent should be liquid. Solvent should be a liquid. The solute may be gas. A solute may be gas, liquid, and solid. Or solid. The solute may be gas, liquid, solid. We have already discussed the gas in liquid. Next we are going to discuss these two type of solution. Here, what is vapor pressure? What is vapor pressure? Suppose you have a water in a beaker. You need a beaker in a closed vessel. What happens? The sum of the water molecule escape and it comes to the gaseous phase. Some of the water molecules comes to the gaseous phase. This is called evaporation. Evaporation. What is evaporation? The conversion of liquid into a vapor. This is called evaporation. The evaporated molecule again condense and converted into a liquid. This is called a condensation. This is called a condensation. Initially, evaporation rate is fast. After some time, the rate of evaporation and condensation the rate of evaporation and condensation becomes equal. ಅಂದ್ರೆ ಎಷ್ಟು ಮಾಲಿಕ್ಯೂಲ್ ವೇಪರ್ ಆಗ್ತದೆಯೋ ಅಷ್ಟೇ ಮಾಲಿಕ್ಯೂಲ್ ಕಂಡೆನ್ಸೇಷನ್ ಆಗಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. ಆ ಕಂಡೀಷನ್ ಅಲ್ಲಿ ಇಟ್ಸ್ ಅಂಡರ್ ಈಕ್ವಿಲಿಬ್ರಿಯಂ. Now the pressure exerted by this vapor when its equilibrium with its liquid is called vapor pressure. This you have studied in the first year. The states of matter ಅಲ್ಲಿ ಕಲಿತಿದ್ದೀವಿ. What is vapor pressure? The pressure exerted by the vapor when its equilibrium with its liquid is called vapor pressure. So the vapor pressure is depends upon the temperature. Vapor pressure is depends upon the temperature. If you increases the temperature, vapor pressure is also goes on increasing. These are the things we have studied in a first year. Now here, what we are going to discuss? Suppose you have a water. Suppose you have water. The pressure exerted by the water is called vapor pressure of the pure water. The vapor pressure of the pure water is represented by P naught. The P naught represents the pure solvent. So the vapor pressure of the water you can take it as P1, P naught. Suppose you have a alcohol, ethanol. Its vapor pressure suppose is called P naught 2. Naught 2 is represent the solute and or second component. 1 is represent the first component. The naught represent the vapor pressure of the pure solvent. Suppose you are mix the water and ethanol. Water ಮತ್ತೆ ethanol ಅನ್ನು ಮಿಕ್ಸ್ ಮಾಡಿ ಅವು ಏನಿರುತ್ತೆ ಎರಡು ವೇಪರೈಸ್ ಇರುತ್ತೆ. ಎರಡು ವೇಪರ್ ಈ ವೇಪರ್ ಅಲ್ಲಿ ಇರುತ್ತೆ vapor of a water and vapor of a alcohol. Here we are not what we are calling it as P1. This P1 is called a partial vapor pressure, and partial vapor pressure of a water. Here P2 is called a partial vapor pressure of a alcohol. P1 is called a partial vapor pressure of the water or the first component, and P2 is called partial vapor pressure of the second component. When this arises, if both are volatile, or you can say a liquid mixture. Liquid, solute, and liquid and solvent. Both are volatile. The vapor pressure of the first liquid is called vapor pressure of the pure solvent P01. You have to remember this term. Otherwise, you will confuse it later. P02 means what? Vapor pressure of the pure component 2. If these two are mixed, then the P1 is called vapor pressure, partial vapor pressure of the first solution. Here only water is vaporized, not the sodium chloride. ಉಪ್ಪು ವೇಪರೈಸ್ ಆಗುವುದಿಲ್ಲ. ಯಾಕೆಂದ್ರೆ ನಾನ್ volatile solute. What is the meaning of non-volatile solute? The solute is not vaporized. Here only the solution contains vapors of water. This is called vapor pressure of the solution, not P01. We are writing it as P1. Why you are writing a P1? Because it's not a vapor pressure of the pure solvent. It's a vapor pressure of the solution containing a non-volatile solute. That means we are going to discuss these two types of solution. One first case, both are volatile. These vapors are called partial vapor. In second case, one is volatile and solute is non-volatile. This solute is called non-volatile solute. In such a case, the vapor pressure is called the vapor pressure of the solution. Vapor pressure of the solution. It is not called either partial vapor pressure or the vapor pressure of pure solvent. It is called vapor pressure of the solution. So let us discuss these two types of solution. The first case is what? Both are volatile. That is called liquid solution. Both the liquids are volatile. Another case is called solid liquid. Another is called, this is liquid. Second is called solid liquid. See, the first case we shall take the liquid and water. Both with the rods. the scientist Rawls has given the relationship between the mole fraction. Already we have discussed the x1 and x2 are the mole fraction. X is used to represent the mole fraction. x1 is the mole fraction of the component 1, x2 is the mole fraction of the component 2. He has given the relationship between the mole fraction and vapor pressure of the partial vapor pressure of the component. So what is the Rawls law says? P1 is directly proportional to x1. Similarly, P2 is directly proportional to x2. How do you define this Rawls law? How do you define the Rawls law? For liquid-liquid mixture, partial vapor pressure of each component is directly proportional to its mole fraction. Similarly, for direct x2, x1 and x2, and 1 and 2. What are P1 and P2? P1 is the partial vapor pressure of the first component and P2 is the partial vapor pressure of the second component. So, what type of solution these are? These are liquid and liquid. Both are volatile. The vapor contains both liquid 1 plus liquid 2. Then its vapor pressure is called P1 and P2. This is a liquid mixture. And what is the Rawls law says? RAOULTS. Rawls law says the partial pressure of each component is directly proportional to its mole fraction. The second for second component also we can write. So the similar expression we have seen in the Henry's law. How do you write? One is directly proportional to x. Here P is what? The partial vapor pressure of the gas in a partial pressure of the gas in a vapor phase is directly proportional to its mole fraction. So it's P1 is equal to P101 into x1. Similarly, P2 is equal to P02 into x2. So what is this P01? P01 is the vapor pressure of the pure component 1 and P02 is what? Vapor pressure of the second component. So this is the Rawls law. What is the Rawls law says? The partial pressure of the for liquid mixture, the partial pressure of the each component is directly proportional to its mole fraction. Clear? See, after that we have studied the Dalton's law last year. What is the Dalton's law says? P total vapor pressure is equal to partial pressure of component 1 and partial pressure of the component 2. So this is the your Dalton's law. Then what we can write? What is P1? P1 is equal to P01 x1 plus P2 is equal to P02 x2. That means you can calculate the total vapor pressure by knowing the what? Partial the vapor pressure of the component, vapor pressure of the pure solvent 1 and vapor pressure of the pure solvent 2 and its mole fraction x1 and x2. You know how to calculate the x1 and x2. What is x1 and x2? x1 is equal to number of moles of first component divided by total number of moles present in a solution. Similarly, x2 is equal to what? x2 is equal to what? n2 divided by n1 plus n2. That we have discussed in a concentration. See, if you know the x1 and x2, we can calculate the total vapor pressure of the solution. So here one more thing is x1 plus x2 is equal to 1. For binary solution, x1 plus x2 is equal to 1. Suppose x1 is equal to 0.75, x2 is equal to 0.25. Total is 1. So you are able to calculate the x1 and x2. This will provide P01 and P02. You are able to calculate the P total. See. We can modify this equation. P total is equal to what? P total is equal to P01 x1 plus P02 x2. What is x2? P01 into 1 minus x2 plus P02 x2. We know that x1 plus x2 is equal to 1. Therefore, x1 is equal to 1 minus x2. Therefore, what is this equation become? P naught 1 minus P naught 1 x2 plus P naught 2 x2. It becomes what? P naught 1 plus P naught 2 minus P naught 1 into x2. P total is equal. See, this is the equation. From this equation, what is clear is the P total is directly proportional to the mole fraction of the x2. Or you can write in terms of x1 also. x1 that means the total vapor pressure is directly proportional to the mole fraction of the component 1 or component 2. So you should remember these two equations. P total is equal to P1 plus P2. This is a Rod's law equation. Also, if another form of this equation equal to P total is equal to P01 plus P02 minus P01 into x2. Clear? So, by knowing the mole fraction of the one component, you can calculate the P total. Or by knowing the P total and P01 and P2, we can calculate the mole fraction of the two components. See, both the type of problem we can do. See, one more. What is x1? What is x1? Mole fraction of the component 1. What is x2? Mole fraction of the component 2. You know how to calculate the x1 and x2. After that, in a vapor, see, these are the mole fraction in a solution. These are the mole fraction in a solution. See, these vaporize contain on P1 and P2. What is the mole fraction in a vapor phase? How do you calculate the mole fraction in a vapor phase? See, suppose you have a mole fraction of the component in a vapor phase is Y1, and similarly Y2 is the mole fraction of the component 2. How do you calculate the Y1 and Y2? See, last year we have studied the P total is equal to mole fraction of that component into the or you can write partial pressure is equal to the total pressure into its mole fraction or mole fraction is equal to P1 divided by P2. What is this Y1? The mole fraction in a vapor phase. What is x1? Mole fraction in a solution. Don't get confused. Y1 andre mole fraction in a vapor phase, and x1 is what? Mole fraction in a solution. Both are different. Yes. Suppose nimge water and alcohol is there. Water and alcohol. Ideno. Idu ಎರಡು ಒಂದು mole ಅಲ್ಲಿ ಇದೆ. How mole fraction is mole fraction of the water is equal to 1 divided by 1 plus 1 2 equal to 2.5 mole fraction of the water. Similarly, mole fraction of the alcohol is also 0.5. Now we know that ethanol is vaporized more than the water. Now the vapor phase contains more I2 compared to the Y1. Here the mole fraction is equal. Here the mole fraction of the ethanol is more than the mole fraction of the water. Therefore, you are able to calculate the mole fraction. These type of questions are asking in your CET at higher level. So that means you are able to calculate the mole fraction in a solution. Mole fraction in a solution is what? x1 and x2, and mole fraction in a vapor phase. To calculate the mole fraction in the vapor phase, you should know the partial pressure of the first component and its total vapor phase. Similarly, Y2 is equal to what? P2 divided by P total. So these are the Y1 and Y2, X1 and X2 and Rod's law. See, graphically how do you represent? Clear? What is the Rod's law says? Rod's law is the P1 is proportional to X1. P1 is proportional to X1. Partial pressure of the volatile component, each component is directly proportional to its mole fraction. Similarly, P2 is equal to X2. Both are volatile. These are the what type of mixture? Liquid mixture. See, second case. See, how do you represent graphically? How do you represent this rod? Already we know that The mole fraction is, this is a vapor pressure, this is a mole fraction. How do you, the mole fraction is directly proportional to vapor pressure. This is the graphically or the component 2 x2. Here at this point x2 is equal to 1. x2 is equal to 1 andre only one component is there. ಇಲ್ಲಿ vapor pressure ಏನಂತ ಇದಕ್ಕೆ, what is called P02. Here what is increases, x2 is increasing. For the other component we can draw the graph like this. For the other component, here this is a x1, here x1 is equal to 1. In this point only pure component 1 is there, here one pure component 2 is there. Its vapor pressure is called P01, its vapor pressure is called P02. In this, these are the mixture of two zones. So if you want to calculate the total pressure, you have to draw like this. This is a P2, this is a P2, this is a P1. How do you calculate? Suppose you want to calculate the P total at this point. See, you will get this answer. See, suppose you move from this end, suppose you move to this end, the total pressure is increasing. Why it is so? For example, if you have water plus alcohol, the alcohol has a higher vapor pressure compared to the water. If alcoholic percentage goes on increases, the total vapor pressure is also increasing. See, this is the graphical representation of your whole. See, what is this one? If you move from this end, alcohol percentage is increases. At that point, pure x2 is equal to 1 and only alcohol is there. Its vapor pressure is called P02. This point, only water is there. Its vapor pressure is called P01. Suppose you are moved from this end, the mole fraction of the alcohol is increases. The P total is also increases. Why P total is increases? Because P02 is greater than P01. Suppose ನಿಮಗೆ alcohol ಗೆ ವೇಪರ್ ಪ್ರೆಷರ್ 200 ಇದೆ, ವಾಟರ್ ಗೆ 100 ಇದೆ. ಈ ಮ್ಯಾಕ್ಸಿಮಮ್ ವೇಪರ್ ಪ್ರೆಷರ್ ಎಷ್ಟಾಗಬಹುದು 200, ಇಲ್ಲಿ ಬಂದ್ರೆ ಎಷ್ಟಾಗಬಹುದು 100. ಇವೆರಡನ್ನು ಮಿಕ್ಸ್ ಮಾಡಿದಾಗ ಇದು ಪರ್ಸೆಂಟೇಜ್ ಒಂದೊಂದು ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋದಾಗ, ಒಂದು ಎಲ್ಕೋಹಾಲ್ ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋದಾಗ ನಮಗೆ ಟೋಟಲ್ ವೇಪರ್ ಪ್ರೆಷರ್ ಕಡಿಮೆ ಜಾಸ್ತಿ ಆಗ್ತಾ ಬರುತ್ತೆ. ವಾಟರ್ ಜಾಸ್ತಿ ಆಗ್ತಾ ಇರೋದಕ್ಕೆ ವೇಪರ್ ಪ್ರೆಷರ್ ಕಡಿಮೆ ಆಗ್ತಾ ಬರುತ್ತೆ. ಮ್ಯಾಕ್ಸಿಮಮ್ ಎಷ್ಟಿರಬಹುದು ವೇಪರ್ ಪ್ರೆಷರ್ 200, ಮಿನಿಮಮ್ ಎಷ್ಟಿರಬಹುದು 100. ಯಾವಾಗ ಸಪೋಸ್ ಇಟ್ ಒಬೇಸ್ ದ ರೋಲರ್ ಲಾ, ಸೊಲ್ಯೂಷನ್ ರೋಲರ್ ಲಾ ಒಬೇ ಮಾಡ್ತೀವಿ ಅಂತ ಹೇಳಿದ್ರೆ, ದಿಸ್ ಇಸ್ ದ ಇಕ್ವೇಷನ್, ದಿಸ್ ಇಸ್ ದ ಗ್ರಾಫ್, ದಿಸ್ ಇಸ್ ದ ಗ್ರಾಫ್. ಕ್ಲಿಯರ್? See, what are the things we have discussed here? We have discussed the vapor pressure of the liquid mixture. What is the meaning of liquid mixture? Both are vaporized. Then the vapor pressure of the first component is called P1, and the vapor pressure of the partial vapor pressure of the first component is called P1. Partial vapor pressure of the second component is called P2. The P01 and P202 are what? Vapor pressure of the pure solvents. ನಿಮ್ಗೆ ವಾಟರ್ ಅಷ್ಟೇ ಇದೆ ಒಂದು ಕಂಟೈನರ್ ನಲ್ಲಿ, ಅದನ್ನು ಕ್ಲೋಸ್ ವೆಸಲ್ ನಲ್ಲಿ ಇಟ್ಟಿದ್ರಿ, ಆ ವೇಪರ್ ಪ್ರೆಷರ್ ಏನಂತ ನಿಮಗೆ P01 ಅಂತೀವಿ. ಅದಕ್ಕೆ ಆಲ್ಕೋಹಾಲ್ ಮಿಕ್ಸ್ ಮಾಡಿಕೊಳ್ಳಿ, ಎರಡು ವೇಪರೈಸ್ ಆಗ್ತದೆ. ಆ ವೇಪರ್ಸ್ ಏನಂದ್ರೆ ಪಾರ್ಷಿಯಲ್ ಪ್ರೆಷರ್ ಆಫ್ ದ ಕಾಂಪೋನೆಂಟ್ 1 P1 and partial pressure of the component P2. How the P1 and P2 are varies, it can be represented by this graph. This is a y-axis is a vapor pressure, this is a mole fraction. Suppose you move this end, mole fraction of the x2 is increases, ಅಂದ್ರೆ ಆಲ್ಕೋಹಾಲ್ ಜಾಸ್ತಿ ಆಗ್ತಾ ಇದೆ. ಈ ಕಡೆ ಬಂತಂದ್ರೆ mole fraction of the water is increasing. ನೋಡಿ, ವಾಟರ್ ಮೋಲ್ ಫ್ರಾಕ್ಷನ್ ಇಲ್ಲಿ ಬಂದ್ರೆ ಇವಾಗ x1 is equal to 1 ಅಂದ್ರೆ x2 is equal to 0, x2 is equal to 1 ಅಂದ್ರೆ x1 is equal to 0. ಎರಡನ್ನು ಕೂಡಿಸಿದಾಗ 1 ಬರುತ್ತೆ ಮ್ಯಾಕ್ಸಿಮಮ್. ಸೊ ದಿಸ್ ಎಂಡ್ ನಲ್ಲಿ ಬಂದ್ರೆ vapor pressure of the only one component is there, it's called P01. This end ಗೆ ಬಂದ್ರೆ only x2 is there, P02. ಈ ಮಧ್ಯದಲ್ಲಿ ಬಂದ್ರೆ in between you will get a mixture. ಈ ಎಂಡ್ ಗೆ ಬಂದ್ರೆ Px2 ಜಾಸ್ತಿ ಆಗ್ತದೆ, ಈ ಎಂಡ್ ಗೆ ಬಂದ್ರೆ x1 ಜಾಸ್ತಿ ಆಗ್ತದೆ. This is the graphical representation of your words law. I think it's clear for you. So this is the one type of solution. What is the one type of solution? Both are volatile. The liquid mixture, the mixture is called liquid mixture. What is the liquid mixture? Both are volatile. Both have the vapor pressure. Both have the vapor pressure. In the mixture, the vapor pressure is called partial vapor pressure. In the pure component, for pure component, the vapor pressure is called vapor pressure of the pure component. P01, don't forget P01 and P02, P1 and P2, X1 and X2. X1 and X2 are the mole fraction in a solution. X1 and X2 are the mole fraction in a solution. How do you calculate the mole fraction? How do you calculate the mole fraction? Already we have discussed how do you calculate the mole fraction. Suppose you have 2 moles of A and 3 moles of B. Then the mole fraction is what? The 2 by 5. 2 by 5 is the first component in the mole fraction of 0.4 is and second component in the mole fraction is 0.x1. X1. Okay, that means you can calculate the partial vapor pressure of the component 1 and partial vapor pressure of the component 2 and the vapor pressure of the pure component are provided. See, the problem is there in the textbook. You are able to calculate the problem. How do you calculate the P total? How do you calculate the P total? P total is equal to what? P1 plus P2. What is P1? P01 X1. See, this P01 and P02 they will provide. ಅದನ್ನ ಕೊಟ್ಟಿರ್ತಾರೆ ನಿಮಗೆ. ಈ ಫಸ್ಟ್ ಏನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು? X1 ಮತ್ತೆ X2. X1 ಅನ್ನು ಹೇಗೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀರಿ? X1 ಫಸ್ಟ್ ಗೆ ಮಾಸ್ ನಲ್ಲಿ ಕೊಟ್ಟಿತ್ತಂದ್ರೆ ಯು ಹ್ಯಾವ್ ಟು ಕನ್ವರ್ಟ್ ಇಟ್ ಇಂಟು ಎ ಮೋಲ್. ಮೋಲ್ ಗೊತ್ತಿತ್ತಂದ್ರೆ ನಂಬರ್ ಆಫ್ ಮೋಲ್ಸ್ ಆಫ್ ಒನ್ ಕಂಪೋನೆಂಟ್ ಡಿವೈಡೆಡ್ ಬೈ ಟೋಟಲ್ ನಂಬರ್ ಆಫ್ ಮೋಲ್ಸ್ ಪ್ರೆಸೆಂಟ್ ಇನ್ ಎ ಸೊಲ್ಯೂಷನ್. X1 X2 ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ರೆ ಯು ಕ್ಯಾನ್ ಈಸಿಲಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ದ P total. One more equation we have written here. ಇದನ್ನ ಈ ಈಕ್ವೇಷನ್ ಯಾವ ಎಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತಾರೆ ಅಂದ್ರೆ if you are asked to calculate the mole fraction present in a solution, ನಿಮಗೆ ಟೋಟಲ್ ವೇಪರ್ ಪ್ರೆಷರ್ ಕೊಟ್ಟಿರ್ತಾರೆ, P01 ಕೊಟ್ಟಿರ್ತಾರೆ, P02 ಕೊಟ್ಟಿರ್ತಾರೆ, ನೀವು ಮೋಲ್ ಫ್ರಾಕ್ಷನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ ಅಂತ ಹೇಳ್ತಾರೆ. then you have to use this equation. I think you are clear. This is a what type of solution? The solution of liquid and liquid. What is that meaning? Both are volatile, both have the vapor pressure, so one more type of solution is a solid in liquid. Already we have discussed a solid in liquid. Suppose you have a water, its vapor pressure is called P01. Suppose it's mixed with you are added a sodium chloride. Now this becomes solution. Its vapor pressure is become P1. Here P2 is equal to 0. Why is P2 is equal to 0? Because sodium chloride is a non-volatile. It will not vaporize. The vapor containing only the vapors of water. Say, suppose you have only pure water, its vapor pressure is called P01. It's a solution, its vapor pressure is called P1. What is P1 here? Vapor pressure of the solution of containing a non-volatile solid. What is P1? P01? Vapor pressure of the pure solvent. See, here always P1 is always less than P01. How do you write the P1? P1 is equal to P01 into X1. You know, X1 is always less than 1 because X1 plus X2 is equal to 1. X1 is always less than 1. Therefore, P1 is always less than the P01. This is the vapor pressure of the solution containing a non-volatile solute is always less than the vapor pressure of the pure solvent. This you have to remember. ಏನರ್ಥ? ನಿಮಗೆ ನೀರಿದೆ, ಇದರ ವೇಪರ್ ಪ್ರೆಷರ್ಗೆ ನೀವು ಏನಂತಾರೆ? ಇದಕ್ಕೆ ವೇಪರ್ ಪ್ರೆಷರ್ ಆಫ್ ದ ಪ್ಯೂರ್ ಸಾಲ್ವೆಂಟ್ P01 ಅಂತ ಹೇಳ್ತೀವಿ. ಹಾಗೆ ಇದಕ್ಕೆ ಉಪ್ಪನ್ನ ಮಿಕ್ಸ್ ಮಾಡ್ತೀರಿ. ಉಪ್ಪು ಅಂದ್ರೆ ಏನದು? ನಾನ್ ವೊಲಟೈಲ್ ಸಾಲ್ವೆಂಟ್. ಹಾಗೆ ಇದ್ರ ವೇಪರ್ ಪ್ರೆಷರ್ ಏನಂದ್ರೆ ವೇಪರ್ ಪ್ರೆಷರ್ ಆಫ್ ದ ಸೊಲ್ಯೂಷನ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಇಲ್ಲಿ ಏನು ನಿಮ್ಗೆ ಗೊತ್ತಿರಬೇಕು? P1 is always less than the P01. Why? The question why? Because in a pure water, the surface is covered by only the solvent molecule. The total surface area is covered by only the solvent molecule. But in a solution, a non-volatile, the sum of the fraction of the surface area is covered by, the fraction of the surface area is covered by what? Solute molecule. This represents a solute. This is a solute. Along with the solvent, sum of the surface area is covered by what? A solute molecule. Therefore, for escaping the solvent molecule, the total area is not available. The fraction of the area is covered by solute molecule. Therefore, vapor pressure is decreasing. Vapor pressure is decreasing. Why the vapor pressure of the solution is less than the vapor pressure of the pure solvent? Because in pure solvent, the total surface area is covered by the solvent molecule only. Therefore, the total is here, the sum of the surface area is covered by, fraction of the surface area is covered by what? Solute molecule. Therefore, this solute molecule is not allowed to escape the solvent molecule. Therefore, vapor pressure of the solution is decreasing. Here, how do you define the Raoult's law? Only now Raoult's law define the vapor pressure of the each component. Why we are using the word vapor pressure of the each component? Because both are volatile. Here what you have to define? How do you have to define? Here also P1 is proportional to X1. What is this P1? The vapor pressure of the volatile component. Vapor pressure of the volatile component is directly proportional to the mole fraction. In general, how do you define the Raoult's law? The vapor pressure of the volatile component is directly proportional to the its mole fraction. Here you cannot write P2 is proportional to X2. You cannot write like this. Why? Because the P2 is equal to 0. Why P2 is equal to 0? The second component is non-volatile. This is the vapor pressure of the solution. What is the solution? What type of solution we have discussed? Liquid and liquid. Here both are volatile, and another is a solid and liquid. Here the second component is non-volatile. The solution is called the non-volatile solid is present in dissolved in a liquid. Here P1 is proportional to X1. What is this P1? The vapor pressure of the volatile component is directly proportional to its mole fraction. See, what you have to remember is always the P1 is less than P01. See, after in the later you are going to study a colligative property. For the cause of the colligative property, this is the criteria. See, why the solution show the colligative property? Because of this reason. What you have to remember here, P1 is less than the P01. For what type of solution we are discussing? The solution of solid in liquid. Here P2 is equal to 0. See, what are we have discussed? Here we have discussed the P01 and P02. The vapor pressure of the pure component and vapor pressure of the pure component 2, and these are mixed. You will get a P1 and P2. Partial vapor pressure of the pure component, partial vapor pressure of the component 1, partial vapor pressure of the component 2, and in the solution number mole fraction X1 and X2, Y1 and Y2 are the mole fraction in a vapor phase. This is a mole fraction in a solution. This is the partial vapor pressure of the component 1 and 2. I think you can calculate the Y1, Y2, X1, X2, P total, all you can calculate. In here they should give the P01 and P02 and X1 and X2. So this is the vapor pressure of the solution. What type of solution we have discussed? Already we have discussed the gas in liquid. That is a Henry's law. And second one is liquid in liquid. That is a Raoult's law, and solid in liquid, Raoult's law. What is the Raoult's law says? X1 is, the P1 is directly proportional to X1. What is P1? Partial vapor pressure of the component 1 or the partial pressure of the each component. Both are volatile, then you have to use the word each component. If only one is volatile, the partial pressure of the volatile component is directly proportional to X. So, I think you are clear. So, this is the third thing we have discussed. Just I am recapping what are the things we have discussed in this chapter. Solution, homogeneous mixture of two or more components. After that we have discussed the binary solution, the solution containing only two components. After that we have discussed the 9 type of solution. This classification is based upon the physical state of the solute and the solvent. There the 9 type of solution we have discussed. Sometimes for the 1 mark question they are asking, give an example for the solution of gas in liquid. Here gas in liquid means what? Liquid is a solvent, gas is a solute. Or the liquid in gas, what is that meaning? Liquid is a solute and gas is a solvent. Or the solution of solid and solid. In earlier exam this question is asked. Give an example of the solution of the solid and solid. Ornamental gold. Copper is dissolved in a gold, or it can give the any other. So here you are able to give the example. After that we have discussed the 7 type of concentration. Out of that you have to remember the molarity, molality and mole fraction. Already the mole fraction has come here. So you have to be able to calculate the molarity of the solution, molality of the solution and mole fraction of the solution. So after that we have discussed the solubility. Solubility of gas in liquid and solubility of solid in liquid. The solubility of solid in liquid is depends upon the temperature. The solubility of gas in liquid is depends upon the pressure and the temperature. How the pressure effect on the solubility of gas is in a liquid is explained by Henry's law. Yesterday we have studied the Henry's law. In ಯಾವ ಟೈಮಿಗೆ Henry's law ಕೇಳಿದ್ರು ಹೇಳಲಿಕ್ಕೆ ಬರಬೇಕು. Henry's law ಅಂದ್ಕೊಳ್ಳಿ ನಿಮಗೆ ಕಣ್ಣು ಮುಂದೆ ಏನು ಬರಬೇಕು? You should not by heart the thing. See what should be come in front of your eyes? The P1 is directly proportional to, sorry, P is directly proportional to X. Henry's law ಅಂದರೆ P ಅಂದ್ರೇನು? Partial pressure of the gas in a vapor phase. X ಅಂದ್ರೇನು? Mole fraction of the gas in a solution. ಇದು ನಿಮ್ಮ ಕಣ್ಣು ಮುಂದೆ ಬಂತು ಅಂತ ಹೇಳಿದ್ರೆ you can write the definition at any time. And mathematical form of the Henry's law you have to write H into X. ಇದು ಎರಡು ಗೊತ್ತಿರಬೇಕು. So ಅದಾದಮೇಲೆ ಟೆಂಪರೇಚರ್ ಎಫೆಕ್ಟ್ ಏನು? ಗ್ಯಾಸ್ ಇನ್ ಲಿಕ್ವಿಡ್ ಅದನ್ನು ನಾವು ಆಲ್ರೆಡಿ ಹೇಳಿದ್ದೀವಿ. ಇನ್ಕ್ರೀಸ್ ಇನ್ ಟೆಂಪರೇಚರ್ ಡಿಕ್ರೀಸಸ್ ದಿ ಸಾಲಿಬಿಲಿಟಿ ಆಫ್ ಗ್ಯಾಸ್ ಇನ್ ಲಿಕ್ವಿಡ್. ಇದನ್ನು ನೀವು ಎಚ್ಚರಿಟ್ಕೊಳ್ಬೇಕು. 2 or 3 times this question is asked in your previous exam. So Henry's law, lot of time every year you can see the one question from the Henry's law. Therefore I am pressing this Henry's law. See after that we have discussed the application of Henry's law. One is you can fill the more carbon dioxide in a soda water or soft drink by filling the gas under high pressure or sealing the bottle under high pressure. One more thing we have discussed, the bends. Bends andrenu? The blocking of capillary due to excess of air dissolved in our blood. See ಸಮುದ್ರದ ಆಳದಲ್ಲಿ ಏನಿರುತ್ತೆ ಪಾರ್ಷಿಯಲ್ ಪ್ರೆಷರ್ ಜಾಸ್ತಿ ಇರೋದ್ರಿಂದ ಬ್ಲಡ್ ನಲ್ಲಿ ಮೋರ್ ಏರ್ ಡಿಸಾಲ್ವ್ ಆಗುತ್ತೆ. ಹೊರಗಡೆ ಬಂದ್ಕೊಂಡು ಏನಂತೆ ಎಕ್ಸಸ್ ಆಫ್ ಏರ್ ಡಿಸಾಲ್ವ್ ಆಗೋದು ಏನಂತೆ ಹೊರಗಡೆ ಬರುತ್ತೆ. ಆವಾಗ ಕೆಪಿಲರಿಯನ್ನು ಬ್ಲಾಕ್ ಮಾಡ್ತಾರೆ. ಆ ಮೆಡಿಕಲ್ ಕಂಡೀಷನ್ಗೆ ಏನಂತ ನಾವು ಬೆಂಡ್ಸ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಈ ಬೆಂಡ್ಸ್ ಆಗೋದ್ರಿಂದ ನಮ್ಗೆ ಲಾಟ್ ಆಫ್ ಪೇನ್ ಬರುತ್ತೆ. ಕೆಲವೊಂದು ಸರಿ ಸಿವಿಯರ್ ಕಂಡೀಷನಲ್ಲಿ ಇಟ್ ಮೇ ಲೀಡ್ಸ್ ಟು ದ ಡೆತ್ ಆಲ್ಸೋ. ಅದಕ್ಕೆ ನಾವು ಏನು ಮಾಡಿರ್ತಾರೆ ದ ಏರ್ ಸಿಲಿಂಡರ್ನ ಹೀಲಿಯಂನಿಂದ ಡೈಲ್ಯೂಟ್ ಮಾಡಿರ್ತಾರೆ. ದಿಸ್ ಯು ಆಲ್ಸೋ ರಿಮೆಂಬರ್. ಅದು ಇನ್ನೊಂದನ್ನು ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ, ಎನಾಕ್ಸಿಯಾ ಅಂದ್ರೇನು? ನಿಮ್ಮ ಆಕ್ಸಿಜನ್ನ ಏರ್ನ ಪಾರ್ಷಿಯಲ್ ಪ್ರೆಷರು ಕಡಿಮೆ ಇತ್ತಂದ್ರೆ ಕಡಿಮೆ ಆಕ್ಸಿಜನ್ ಈ ಬ್ಲಡ್ನಲ್ಲಿ ಡಿಸಾಲ್ವ್ ಆಗುತ್ತೆ. ಅವಾಗ ಆ ಕಂಡೀಷನಿಗೆ ಏನಂತೇವೆ ಎನಾಕ್ಸಿಯಾ. ಅವಾಗ ಪರ್ಸನ್ ಕ್ಯಾನ್ ನಾಟ್ ಥಿಂಕ್ ಕ್ಲಿಯರ್ಲಿ, ಸೊ ಹಿ ಬಿಕಮ್ಸ್ ವೀಕ್. ಸೊ ದಿಸ್ ಮೆಡಿಕಲ್ ಕಂಡೀಷನ್ ಇಸ್ ಕಾಲ್ಡ್ ಎನಾಕ್ಸಿಯಾ. ಸಿ ಆಫ್ಟರ್ ದಟ್ ವಿ ಹ್ಯಾವ್ ಡಿಸ್ಕಸ್ finally we have discussed what? Vapor pressure. Vapor pressure nalli we have discussed the 2 type of solution. Already we have discussed the gas and liquid in a Henry's law. The liquid and liquid, what is that meaning? Both are volatile. See solution vapor inde enirutte eradu vapor irutte. Avaga rods irutte. Partial pressure of each component is directly proportional to the mole fraction. So similarly partial pressure of the second component is also directly proportional to the mole fraction. See one more type of solution we have discussed is a solid in liquid. ಇಲ್ಲಿ ಯಾರು ಮಾತ್ರ ವೇಪರೈಸ್ ಆಗ್ತಾರೆ? ಲಿಕ್ವಿಡ್ ಮಾತ್ರ ವೇಪರೈಸ್ ಆಗ್ತದೆ. ಸಾಲಿಡ್ ಈಸ್ ಕಾಲ್ಡ್ ನಾನ್ ವೋಲಟೈಲ್ ಸಾಲಿಡ್. ಆಗ ವೇಪರ್ನಲ್ಲಿ ಏನಿರ್ತದೆ, ಓನ್ಲಿ ದ ವೇಪರ್ ಆಫ್ ದ ಕಾಂಪೋನೆಂಟ್ 1. ಅದಕ್ಕೆ ನಾವೇನಂತೀವಿ, ಇದಕ್ಕೆ P1 ಅಂತೀವಿ, ನಾಟ್ P01. ಯಾಕಂದರೆ ಇದು ವೇಪರ್ ಪ್ರೆಷರ್ ಆಫ್ ದ ಸೊಲ್ಯೂಷನ್, ವೇಪರ್ ಪ್ರೆಷರ್ ಆಫ್ ದ ಸೊಲ್ಯೂಷನ್ ಕಂಟೈನಿಂಗ್ ಎ ನಾನ್ ವೊಲಟೈಲ್ ಸಾಲ್ಯೂಟ್. ಓಕೆ, ಸೊ I think you are clear. I will give the notes in a, I will post the notes in a WhatsApp. ಈ ಕ್ಲಾಸನ್ನು ಕೇಳಿ, ಕ್ಲಿಯರಾಗಿ ಕೇಳಿ. ಸಪೋಸ್ ನಿಮ್ಗೆ ಏನಾದರೂ ಸಮಸ್ಯೆಗಳಿರ್ತಂದರೆ, ಪ್ರಾಬ್ಲಮ್ಗಳಿರ್ತಂದರೆ ನೀವು ವಾಟ್ಸಪ್ನಲ್ಲಿ ಪೋಸ್ಟ್ ಮಾಡಿ. ನೀವು ಕ್ಲಾಸ್ ಕೇಳ್ತಾ ಇರಬೇಕಾದ್ರೆ ಏನಾದ್ರು ಸಮಸ್ಯೆಗಳು ಬಂದರೆ ಚಾಟ್ ಬಾಕ್ಸ್ನಲ್ಲಿ ಹಾಕಿ. ಮುಂದಿನ ದಿನಗಳಲ್ಲಿ ನಾನು ಆಲ್ಮೋಸ್ಟ್ ಸ್ಟ್ಯಾಂಡರ್ಡೈಸ್ ಮಾಡಿದ್ದೀವಿ. ಆದರೂ ಏನೋ ಸಮಸ್ಯೆ ಬರ್ತಾ ಇರುತ್ತೆ. ಇವತ್ತು ಬೆಳಗ್ಗೆ ಬಂದಿದ್ದೀವಿ, ಎಲ್ಲ ಕ್ಲಾಸ್ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ್ದೀವಿ, ಸಡನ್ಲಿ ಕರೆಂಟ್ ಹ್ಯಾಸ್ ಗಾನ್, ನಮ್ಮ ನೆಟ್ ಕನೆಕ್ಷನ್ನು ಹೋಗ್ಬಿಡ್ತು. ಅದಾದಮೇಲೆ ರಿಪೇರಿ ಮಾಡುವವರಿಗೆ ಸ್ವಲ್ಪ ಟೈಮ್ ತಗೊಳ್ತು. ಮುಂದಿನ ದಿನದಲ್ಲಿ ಹೀಗಾಗೋದಿಲ್ಲ ಅಂತ ನಾವು ಸೀರಿಯಸ್ ಕೊಡ್ತೀನಿ. ನೀವು ಫಾಲೋಅಪ್ ಮಾಡಬೇಕು, ಡೈಲಿ ಫಾಲೋಅಪ್ ಮಾಡಬೇಕು. ನಮ್ಮ ಕ್ಲಾಸನ್ನು ಸ್ವಲ್ಪ ಅಡ್ಜಸ್ಟ್ ಮಾಡ್ಕೊಳ್ಬೇಕು. ಬಿಕಾಸ್ ನಮಗಿರುವಂಥ ಲಿಮಿಟೆಡ್ ಫೆಸಿಲಿಟಿಯಲ್ಲಿ ನಾವು ಇದನ್ನು ಮಾಡ್ತಾಯಿದ್ದೀವಿ. ನಮಗೆ ಒಂದ್ಸೇ ಸ್ಟ್ಯಾಂಡರ್ಡೈಸ್ ಆದಮೇಲೆ ಮುಂದಿನ ದಿನಗಳಲ್ಲಿ ಸಮಸ್ಯೆ ಬರುವುದಿಲ್ಲ ಅಂತ ನನ್ನ ಆಸೆ. ಹಾಗಾಗಲಿ ನಿಮಗೆ ಇದು ಪ್ರಯೋಜನ ಆಗ್ತದೆ ಅಂತ ನಾನು ತಿಳ್ಕೊಂಡಿದ್ದೀನಿ. ನಿಮಗೇನಾದ್ರು ಸಮಸ್ಯೆಗಳಿತ್ತಂದರೆ ನೀವು ದಯವಿಟ್ಟು ನಮಗೆ ನಿಮ್ಮ ಅನಿಸಿಕೆಗಳನ್ನು ಹೇಳಿ. ಮತ್ತು ಈ ನಮ್ಮ ಯೂಟ್ಯೂಬನ್ನು ರಘುವೀರ್ ನಾಯಕ್ ಬ್ರಾಡ್ಕಾಸ್ಟಿಂಗ್ ಅಂತ ಒಂದು ಯೂಟ್ಯೂಬ್ ಇದೆ. ನಾವು ಫಸ್ಟಿಗೆ ಅದನ್ನು ಹೆಚ್ಚು ಬೆಣ್ಣೆ ಗೌರ್ಮೆಂಟ್ PU ಕಾಲೇಜಲ್ಲಿ ಮಾಡಿದ್ವಿ. ಅದರಲ್ಲಿ ಯಾಕೋ ಲಾಗಿನ್ ಆಗಲಿಕ್ಕೆ ಆಗ್ತಾಯಿಲ್ಲ. ಈಗ ರಘುವೀರ್ ನಾಯಕ್ ಬ್ರಾಡ್ಕಾಸ್ಟಿಂಗ್ ಅಂತ ಇದನ್ನು ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಅದನ್ನು ಎಲ್ಲರೂ ಸಬ್ಸ್ಕ್ರೈಬ್ ಆಗಿ. ಒಂದು 1000 ಸಬ್ಸ್ಕ್ರೈಬರ್ ಆದರು ಅಂತ ಹೇಳಿದ್ರೆ ನಾವು ಯೂಟ್ಯೂಬ್ನಲ್ಲಿ ಡೈರೆಕ್ಟ್ ರಿಲೇ ಮಾಡ್ಬೋದು. ನಮಗೆಲ್ಲ ಸಮಸ್ಯೆನೂ ಹೊರಟೋಗ್ತದೆ. ಅದಕ್ಕೆ 1000 ಸಬ್ಸ್ಕ್ರೈಬರ್ಗಳನ್ನು ಮಾಡಿಸಿ. ಆದಷ್ಟು ಮುಂದಿನ ದಿನಗಳಲ್ಲಿ ನಿಮಗೆ ಕ್ವಾಲಿಟಿ ಕ್ಲಾಸನ್ನು ನಾವು ಕೊಡಲಿಕ್ಕೆ ಇಷ್ಟಪಡ್ತೀವಿ. ನಾಳೆಯಿಂದ ನಿಮಗೆ ಕರೆಕ್ಟಾಗಿ ಟೈಮ್ ಟೇಬಲ್ ಕೊಡ್ತೀವಿ, ಯಾವ ಕ್ಲಾಸು ಎಷ್ಟು ಗಂಟೆಗೆ ಅಂತ. ಸೊ ನೀವು ಫಸ್ಟು ಟೈಮಿಗೆ ಬಂದು ಕುಳಿತುಕೊಳ್ಬೇಕು. ಎಲ್ಲರೂ ಟೈಮಿಗೆ ಬಂದು ಕುಳಿತುಕೊಳ್ಬೇಕು ಮತ್ತು ಕ್ಲಾಸನ್ನು ಕ್ಲಿಯರಾಗಿ ಕೇಳಬೇಕು. ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು.